question, question 2, has to do with a color being dropped from a position. So the question goes like this. Color C, 0.5 meters. Okay. So the question goes like this: a 5 kilogram color, 5 kilogram color C is released from rest in the position shown and slides without friction on a vertical rod until it hits a spring with a constant of K equals 720 newtons per meter. That compresses the velocity of the collar is then reduced to 0, and the collar reverses direction. So this velocity is dropping, hits here, reduces to 0, and then reverses direction. So the collar drops and reverses direction. And returns to its initial position. The circle is then repeated. Determine 1. The period of the motion of the collar, motion, and the velocity of the collar, 0.4 seconds after it was released, and velocity 0.4 seconds after release. We proceed as follows. First is to take, for example, that we recall omega n for a spring is equal to the root of the K over M, which is 720 over the mass of the collar over the mass of the collar, which is 5 kilograms. Root is equal to 12 rads. Okay. Now, recall that the mass was dropped through a height. So, to find the velocity is going to hit, which it will hit the spring, we are going to recall that V is equal to 2GH, the root. So, and that is 2 times 9.81 times H, which was 0.5. Okay. And we take the root, we are going to arrive at 3.132 meters per second. Now, to get the time of flight, we know that S is equal to half for a falling body is equal to S is equal to half GT squared, which implies T is equal to the root of twice the S, the distance, by G. So this is 2 times 0.5 over 9.81, so root is equal to 0.93 seconds. Okay. So right now we have obtained the time it takes to hit the spring and the velocity with which it hits the spring. Next, is to note that the static extension is equal to the W over K, right? So it's going to be 5 times 9.81, that's mg over k. So 5 times 9.81 divided by 720. This gives us the static deflection of the spring. Now, we can write the differential equation of the spring in this form to be m double x plus 720 x is equal to 0. 5 from m double dot x plus kx is equal to 0. So we have written the equation of the spring. So x we can write in simple harmonic motion to be xm sine omega nt plus psi plus phi. Okay. Then if we want to obtain the velocity, which is x dot, we are going to differentiate this once. So to do that, if we differentiate, we will have xm omega n cos omega nt plus phi. And then as impact, we are considering when the collar hits the spring, at the impact of the spring, considering the spring at that impact. So at impact, T is equal to 0 for the spring, and the x of the spring is 0.068125, which is the static deflection. Okay, the x is the original position of the spring. Now, we know that the velocity v is equal to because it's going downwards, the velocity will be negative 3.132 meters per second. So we can now put these two values into the equation of motion. So if we write the equation of motion, we can write that, remember, we call x equal to xm sine omega nt plus phi. So if I do that, and t is 0. So at t is 0, we will have x equal to xm sine. Instead, I will no longer have the omega nt term. I will only have the phi term. And then similarly, I will have v to be equal to minus 3.132 equal, this is for the velocity now, which is xm times omega n cos omega nt, which is 0 plus phi. So everything becomes 12 xm cos phi. If I solve these two equations simultaneously, equation star, star, if I solve simultaneously, we will obtain that xm is equal to minus 0.269575 meters, and phi is equal to minus 0.25531 rad. Now, the T2, let's look for the time Okay, let's look for the time. Remember that at the time it hits the collar, its velocity is going to be 0. So that time is x dot of t is let's call it t2 is equal to 0. So recall that the formula for x dot is 12 times t 2 plus 5, and then this 0 can be written as pi over 2. Okay. This is on this side, and this is the cos inverse of 0. Okay. So we have this. Next, we can obtain T2 to be, implies that T2, where it has 5, is equal to 0.15217 seconds. Hence, we can therefore write the period, which represents the total time of movement, times 2. So period is equal to 2 into T1 plus T2. And that is 2 into 0.3193 plus 0.1522. And that is 0.94274 seconds. Then after 0.4 seconds, we want to find the velocity. So velocity v is equal to x dot at 0.4, which is equal to xm omega n cos omega n 0.4 minus t1 plus 5. So it's minus 0.4 because it must cover the first t1. Okay, it's minus t1 because it must cover t1 during the 0.4 time. Okay, so we will have, if I put every value I have into this equation, we are going to have that is equal to 12 minus 0.26975 cos 12 times 0.4 minus 0.1393 minus 0.25531, and everything turns out to be minus 2.448 meters per second.